Okay, so which one is rational? So I'm looking for something that is predictable. And so if I'm thinking about pi, hopefully you know that's definitely not going to work. This is non-perfect. So this one won't work. That's not rational. And so really I'm trying to check to see which one of these is predictable. So if I'm looking, this is 625, 625, and so 625, 625. So I can assume that hopefully this is going to keep repeating, whereas this one does not. It's just random. So this is not rational, but this one is because it's predictable. Square root of 5, like we said here, is non-perfect. If I'm thinking of a number line where this is the square root of 1, 4, and 9, the square root of 5 would be like here. So I'm really looking for a number that's kind of right past 2, and it's not perfect. So because it's not perfect, that means it's irrational. Okay, 11 over 21. So I know it's rational because it's a fraction, right? So that part I definitely know for sure. If I'm reading through these, I don't even need to know what 11 over 21 is to be able to answer it. It says the decimal expansion includes more than 5 digits past the decimal point. Well, that doesn't tell me if it's rational or not. That just tells me how long it is. But if it repeats, it could still be more than 5 digits. So that doesn't give me information that works to tell me one thing or the other. If it repeats the same sequence of numbers, then that would make it rational. So that could be a reason something's rational, is that it repeats. So that makes sense. That's a reason. The decimal expansion has less than 1 in the numerator. Oh, less than 1 because the numerator is smaller than the denominator, meaning this is not an improper fraction, but we don't know anything. Improper fractions don't tell us anything. And then the decimal expansion does not have a repeating sequence of numbers. Well, I mean, I can check to see if it repeats or doesn't repeat. So if this one says it doesn't repeat, this one says it does. But if I know it's rational, this doesn't tell me it's rational, that it doesn't repeat. So I know this isn't the reason I know it's rational. The only one of these that's a reason for something being rational is the idea that it repeats. Because not repeating, it could end. So I don't really know what that means. But this is specific. If it repeats, it's definitely rational, so it has to be this. Okay, which ones are rational? So, repeating decimals, that's definitely rational. This is non-perfect square. We just talked about that twice. This is a perfect square, though. It equals 4. This is a fraction with regular numbers, so that's good. And then this decimal, I have to check through to see if it repeats, but you can tell it's definitely random, so it does not. So really, if I'm looking, this works, and this works. Same thing here. Which of the following decimals appear to be rational? So I'm really checking to see if it either ends or repeats. So this one repeats, right? I could put a bar over that. I'm sorry, that would be A, so I'm circling that. 6 definitely repeats here, right? So that one works. 0, 6, 2, 5 ends after 5. So that works. This terminates. This is a whole bunch of random numbers. And this is a whole bunch of random numbers. So as far as rational, A, B, and C. So predictable. These are unpredictable. Okay. Which one is going to be closest to 10? I mean, I can definitely go through and predict these. But the other thing I can do is just use my calculator, right? So if I have access to a calculator on this test, let's see. So 3.14 times 3.14, 9.8596. So this is 3 times the square root of 8. And the square root of 8 is 2 point something. So 3 times the square root of 8 is going to be 8.48 some other stuff. So 8.4852 ... So it doesn't repeat, goes on forever, because that's non-perfect square roots. Square root of 83 is also a non-perfect square root. So square root of 83 is 9.1104 ... So non-perfect. And then 3.14 plus 6 is about 9.14. So I can kind of compare those to see that definitely pi squared is going to give us the biggest answer. So that one's the closest to 10. So just a reminder, you do have access to a calculator on this. All right, which two numbers does the square root of 27 lie between? So you're really deciding it's between the square root of 25 and 36. So it's between these two perfect squares, which means it's between 5 and 6 on the number line. And it's definitely closer to 5, right? So it'd be like maybe 5.2 or something, but between 5 and 6. Square root of 45 is between 36 and 49. And this time it's pretty close to 49, which is 7, right? So this is square root of 49 here is 7, which means this point is the one that's right before that. So 45 would be right before 49. And then square root of 8, so again, if I'm looking at these as square roots, this is the square root of 1, square root of 4, square root of 9. So the square root of 8 would be right before that. So Q. Because 8 is definitely closer than it wouldn't be on the 2. All right, which number line shows points plotted at the square root of 7 and the square root of 23? So the square root of 7, so if I label these, this would be 4, 9, 16, 25. So square root of 7, that makes sense here. And then square root of 23 would be right before 25. So that makes sense. So this would be right before 9 and 25. If you look at the next answer, this one shows the same thing, but this time it's closer to the square root of 4. But if you look, really 7 would be closer to 9 than 4, right? So I don't think this one makes sense. This one is not in the right spot, because this is the square root of 16. So this dot is too close to that to be 7. It's not close enough. And then this spot here makes sense, but again, this one, if I'm looking, this is square root of 16 and 25, but 23 should be closer to 25, so it should be more in that position, so it'd be A. Okay, we did go through this yesterday, but just in case you forgot, if I'm trying to check to see if something is a right angle here for a right triangle, then I'm checking to see these lengths. I just need to put the largest one in the space of the hypotenuse. And then I'm checking to see, is a squared plus b squared equal c squared? Or in regular words, is leg squared plus leg squared equal to hypotenuse squared? So I'm checking that. Is that true? So the way that I check that is to plug these in. This is my leg, and then the one across is my hypotenuse. So 5 squared plus 12 squared, and I'm checking to see, does that equal 15 squared? So 25 plus 144, and that's 225. So is this equal? Hopefully you say no. So 169 and 225, so that means no, this is not a right triangle because of that. Right? That's what it says here. 5 squared plus 12 squared does not equal 15 squared. Alright, so we talked yesterday about the idea that if you have 8 squared, this is 8 squared, because it's literally 8 by 8, which is 64, right? And then this is 6 squared, because it's 6 by 6, which is 36. And so if you take these two and you add them together, then it is going to total up to that square, which is 100. And this square is 100, which means that the sides need to be the same, right? And so I'm looking for a number that when I multiply it by itself, it equals 100, which would be 10 times 10. So this is a square that has a side length of 10 and an area of 100. So basically you're saying 8 squared plus 6 squared equals 10 squared. Right? So in this triangle, if I'm paying attention to just the triangle here in the middle, right, I'm really saying leg squared plus leg squared equals hypotenuse squared. So this is kind of just like a visual representation of what that looks like, that answer. Here's the same thing. It just wants you to describe it in words, and I know it has this weird math processing error here, but it doesn't really matter, because what it's asking for is, it's basically saying, what does this figure represent? So the sum of the square of A and the sum of the square of B should be equal to the square of C. So if you look through these, all of these use this word square root at some point, and this is not a picture of a square root. This is definitely pictures of squares, right? So it's basically saying square A plus square B equals square C. Alright, here's Luke with his television, and he wants to know how much the diagonal is here. He does know this is 20 and 30. And so if you're thinking of that right triangle, it's really 20 squared plus 30 squared, right? Leg squared plus leg squared. And you're trying to figure out what this is. So it's 20 squared plus 30 squared does not equal the question mark. That's not true. It really equals the question mark squared. So if it equals the question mark squared, the way that you get rid of that squared idea here is to take the square root. And so you have to take this square root here. So if you type 20 squared plus 30 squared into a calculator, and then you take the square root of it, that's going to tell you how long this side is, which is like 36.0 something something something. So the step really is to take both sides and square them, and then add it together and take the square root. So square both numbers, add them, take square root. So those are the steps really. So square both numbers, add them, take the square root. So if I apply that to the next problem, because I'm trying to find that same number, so I'm going to square both numbers, so 16 squared, 12 squared. I'm going to add them, and then I'm going to take the square root. Because it's really based on that formula. So this would give me the answer. And if I type that into my calculator, that's going to equal 20. Okay, the issue is what happens here when you don't have a leg anymore. So now if I label this, this is leg here and leg here, because that's where my 90-degree angle is. So that means this is the hypotenuse. So this time, if I'm thinking about a squared plus b squared equals c squared, that leg squared plus leg squared equals hypotenuse squared. This time I have 9.8 squared plus something squared equals 12.7 squared. So in this situation, I need to move some stuff around, right? I need to isolate this question mark by subtracting the 9.8 squared. So if you look at this math problem, this says 12.7 squared minus 9.8 squared. So if I go back to this rule, this list of steps here I had, remember how I said square both numbers? So here I took the two numbers I had and I squared them. So I still have to square both numbers. The difference is in this time I subtracted them instead of added them. So that's kind of a summary. So let's write that down so that you can see it. So if you're missing the hypotenuse, you're going to square both numbers, add them, and take the square root. If you're missing a different side, like on this other problem, if you're missing a leg, like on this problem number 16 here, so if I'm missing a leg, then I still square both numbers, but this time instead of adding them I subtract them and then take the square root. So basically those are the two different things I do for every problem. So let's use those two post-its then on the next page. Oh, so let's figure out what this is first. So basically, after subtracting here, I'd need to take the square root. So if I figure out what that is, 12.7 squared minus 9.8 squared and then if I take the square root, I end up with 8.077, which we could round up to 8. So really this is about 8.08 or something like that. Oh, look, they even rounded to 8.1, so if you round to the nearest tenth, it'd be 8.1. Okay, so as I was saying, if I'm looking for problems now, basically I just need to decide, am I missing a hypotenuse or am I missing a leg? So if I look through this picture, my 90-degree angle is here, which means my hypotenuse is here, right? So that means I'm missing a leg. So this is going to be this situation, where I'm missing a leg. So I need to square both numbers. So 25 squared, 19 squared. This time I'm going to subtract them. And then afterward, the last thing I need to do is take the square root. So you have access to a calculator. So the square root of 25 squared minus 19 squared equals 16.25. So about 16 feet. Okay, moving on. Here I have the situation with the ladder. Very good chance you'll see something like this on AZ Merit or Benchmark. So if I kind of turn this triangle to the side here, basically what I have is I have this ladder leaning up against the wall, right? And the wall is 90 degrees with the ground. So this is the ground, the wall, and the ladder. This is 4.5, and the ladder is 18. So I am missing a leg again. So again, it's going to be that situation. So I'm going to square both numbers, subtract this time, and take the square root. Another way that you can look at this is, are you trying to find the short side or the large side? So the hypotenuse is the long side, so if you're trying to find the longest side, you do this. If you're missing a leg, you're trying to find a short side, one of the shorter ones. So this answer is 17.43. 17.43. So if I'm looking, my approximate height is about 17.5 feet. Okay, still talking about ladders and things. If you look at this problem, here's my triangle this time, right? So my right angle's here. So this time, if I'm looking across, I am missing the hypotenuse. This is the side I don't know. So this time I'm doing a missing hypotenuse, the longest side. So since I'm trying to find the longest side, this is where I add them. So I'm going to square both numbers, add, and then take the square root. So this is 25 plus 144. Which is the square root of 169, which equals 13. This one's similar, but this time, instead of finding a leg, or the hypotenuse, I have that hypotenuse, so I'm trying to find the leg. So this time I'm using this list of steps. So I'm going to square both numbers, subtract, and then take the square root. So 41 squared minus 9 squared, which equals 40. Okay, last one. That's the Pythagorean theorem problem. So last triangle, right angle's here, hypotenuse is 80, so that means I'm finding a leg. So I'm going to use the subtraction step. So I'm going to square both numbers, subtract, and then take the square root. So this turns out to be about 58.1. So to the nearest foot is 58 feet. Okay, which of these statements is correct? X squared is 4, then x is 16. So then you're plugging 16 in here. So you're saying 16 squared equals 4. That's not true. Bet a lot of people got tricked by that, though. Here you're plugging in 4, so you're saying 4 squared equals 64, which that's not true. Here you're plugging in 9, so you're saying 9 squared equals 81, which that is true. This one is saying 24 here, so 24 to the third power equals 8. No way. 5 to the third power equals 125. That is true. Check it if you don't know that. And then 6 to the third power, so 36 times 6 is 216, and that is true also. So just checking to see if you understand what it means by squared. You know, 16 times 16 is not 4. Whereas 9 times 9 is 81, 5 times 5 times 5 is 125, etc. Okay, scientific notation, one of the other new things we need to do. So, scientific notation has one number to the left of the decimal, and it's multiplied by a power of 10. So it's going to have 10 with some kind of little exponent on it. But you're going to have an x out front that's going to say times 10 to the whatever power. So if I'm trying to put this in scientific notation, I know that since I have 2.5 here, I know I'm going to have 2.5. Because I want to have one number on the left side of the decimal here. So basically I'm going to move it so that the decimal's there. And I have to do times 10. But I need to move it in the direction, I need to count how many times I move it, basically. So 1, 2, 3, 4, 5, 6, 7 times. And so then the last step is it big or small? If you have a big number, then that means you have a positive exponent on your 10. And if you have a small number, that means you have a negative exponent on your 10. So this was a small number, right? 0.00000025. So this would be a negative 7. So 2.5 times 10 to the negative 7 really is kind of like saying 2.5 divided by 10 7 times, which is why that ends up getting so small. So this would be 2.5 times 10 to the negative 7 because I move it 7 times in the direction that makes it small. Okay. Which number is correctly written in scientific notation? So that goes with this. It has to have one number on the left side. So I can tell you right here, this doesn't have a number on the left side. It has a 0, so that doesn't work. This, 3,892, has a decimal here, which means it has 4 numbers. So that doesn't work. This one has 2 numbers on the left side, so that doesn't work, whereas this one has just 1, right? So that's good. Okay, 8 times 10 to the negative 6. So first of all, this has a negative exponent, which means when I'm done, it's going to be a small number. It also means I'm going to move my decimal 6 times, because it's a 6. So I have 8, right, and my decimal's here, because the number is 8, which is really the same as 8.0. So I need to move the decimal 6 times in the direction that's going to make 8 small. So hopefully you can tell that means I need to move this way. So I'm going to move it 1, 2, 3, 4, 5, 6 times. And I fill in all those zeros, right? So really I'm saying 1, 2, 3, 4, 5 zeros with an 8. So 1, 2, 3, 4, 5, 6. That's too many. That has a negative sign. Doesn't make sense because this is a positive number, right? Positive 8, so it should be positive. So that doesn't work. 1, 2, 3, 4, 5. So that makes sense. 1, 2, 3, 4, 5. So that's the right amount. Oh, look at that. 24 and 26 are the same question. Lucky you guys. D. Alright, exponents. If you look at this exponent, basically this says 6x, x, x, y, 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 and then 2. And then these x's, when they're negative, are really saying division. So the trick is, if you flip your negative exponent over the fraction bar, it switches the sign. So really this means I could move this x up here and it becomes a positive 3, and I can move that y up here and it becomes a positive 3. So that's what I'm going to do, is I'm going to take those and move them up. So that really adds 3 more x's here and 3 more y's. So what I'm trying to figure out is, what does all of that simplify to if I start combining stuff? So if I'm multiplying 3x's here and 3x's here, really that's 6x's altogether, right? And same thing with y's. 3 here and 3 here means I'm multiplying 6 of them all together. And this is just a division problem. 6 divided by 2 is 3. So this is really 3x to the 6th, y to the 6th. Okay, same thing here. 7s, right? So I have 7 times 7 times 7 times 7 times 7. And that's over 8 of them. So there's my two expressions expanded, and every time I have a fraction, 7 over 7, that really just equals a 1. So it kind of like cancels out. You can almost look at it like it goes away. Same thing here, 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 here. So these all cancel and just equal a 1. So it's saying 1 times 1 times 1 times 1, so it just doesn't change anything. It just goes away. This, though, has a 7 times 7 times 7 on the bottom. So really I have 1s on the top, right, left over. And then I have 7 times 7 times 7, so 7 to the 3rd. So this is what this equals. And so now they're asking you to go through and kind of do the same thing with these. Can you simplify these and see if it equals the same thing? So here, if you're looking for a shortcut, really what I did is I subtracted 5 here. 8 minus 5 is what left 3 behind. So if I subtract 4, this would be 1 over 7 to the 5th. So that's not the same. Here, since I have more on top, I would subtract 6 from the top. So I end up with 7 to the 3rd on top over 1. So that's close, but it's not the same, right? Because this is on the bottom and that's on the top. This 7 to the negative 3 looks pretty similar, but a positive 3 and a negative 3 are not the same number when they're on the bottom together, so that's not true. This, if I think about rewriting, so if I move this down to the bottom, like what we did up here, if I flip it over to make it positive, it becomes 1 over 7 to the 1 and then 7 to the positive 2, which means on the bottom here I have 3 altogether, right? So that's the one that matches. Okay, which one's equivalent to 3 squared times 3 to the 6th? So 3 squared, oops, that's not what I meant to do. 3 squared, and then times 3 to the 6th. Right, so here's my squared, here's my to the 6th, which means altogether, if I total them up, I'm really just adding 2 plus 6 here to say that it's 3 to the 8th. So one thing I will say on these answers where there's a 9 at the bottom, hoping kids will do 3 times 3, the base never changes. So when you're working on exponent problems, this is something you can just remember. The base never changes. Okay, which is not equivalent to 1 over 36. So 6 times the negative 1 times 6 to the negative 1. So if you think about this as a fraction, both of these could get flipped. So I end up with 6 to the positive 1 times 6 to the positive 1, which is 1 over, so I have 2 6's, so 6 squared, which is 1 over 36, so that is equivalent, so that's not right. If I flip this one, I have, let's change colors so you can see the difference. 6 squared on top over 6 to the positive 4 on the bottom. And so again, I would need to subtract this 2 from the bottom. So I end up with 1 over 6 squared, which again is 1 over 36. So this doesn't work. Alright, switching this, I have 6 squared over 6 to the 1. So this time I have 6 squared on top, which is 36, not 1 over 36. So this is not equivalent. This is true. So let's double check the last one. So I'm going to move that one down, right? So I have 6 over 6 to the positive 3. And so if this is an invisible 1 here, again, I have to subtract this. So I do end up with 1 over 36 again. So this is the only one here that was not 1 over 36. Okay, which one is equivalent to this? So 4 to the 5th means 4 times 4 times 4 times 4 times 4. 4 to the negative 5th is really like saying there's a fraction here that you can flip it over. So it's really 1 over 4 times 4 times 4 times 4 times 4. Because really, if this is multiplication, this really means divide. 4 to the negative 5th means divide by 4 5 times. So it has not a negative answer. It has nothing to do with whether the answer is negative or not. So just pointing out that that has nothing to do with it. All right, last question. If you're looking at all these tens, basically I'm just trying to total up how many there are, keeping track of the idea of like fractions and things. So I have 4 tens here. This is an invisible 1 there, and then 2 more there. So altogether, if I'm thinking about how many are on top, I have 4 plus 1 plus 2. So 5 plus 2 is 7, so 10 to the 7th over 10 to the 10th. And so again, if I have 7 on top and 10 on the bottom, I can take the 7 on top and subtract it from the 10 that are on the bottom. And I end up with 1 left over on top, 10 to the 3 on the bottom. You'll notice this answer isn't here, and they want you to write it as a negative. So the idea is that if you move this back up to the top, it'll switch to a negative, which would match this. Okay, hopefully that made sense. And that's it, we're done.